All right, 1551 at 2000, the equilibrium constant for the reaction is, and I've got it written down here twice because I didn't write it super good there. If the initial concentration of NO is, what are the equilibrium concentrations? So this is one where you want to make an ICE table, ICE, and then we'll plug in the things that we know. So we know that the initial concentration of NO is 0.175, which we're going to assume there's none of this and none of this to start with. And then when we achieve equilibrium, we will lose 2x of this, because there's a 2 in front of here. We will gain x of this, and we'll gain x of this. So at equilibrium, we'll have 0.175 minus 2x, and we'll have x amount here and x amount here. Now, when we write the equilibrium constant expression, it would be the products, so O2 times N2, divided by NO, and we would square that because there's a 2 right here. And our products would be x and x, so we'd end up with x squared here on the top. And then on the bottom, it would be 0.175 minus 2x, and this would also be squared. And this would be equal to 2.4 times 10 to the third, our K value right up here. So it looks like we have to FOIL this, but there's a trick. We could actually just take this whole thing, raise it to the 1/2 power, if we take this side and raise it to the 1/2 power, or in effect square root both sides, because now my squares go away and I just have to find the square root of this number, and now x over 0.175 minus 2x is equal to 2.4 times 10 to the third, and now I just have some algebra to do rather than the quadratic equation to finish. So bringing this over to this side over here, I end up with x equaling 2.4 times 10 to the third times 0.175 minus 2x, and then I would distribute this in to find each of those, and then I would gather the terms over here to get the x by itself. And after I do that, I have x equaling 0.08662, and now I can take the x and I can put it back into my equation right up here to find the equilibrium amounts of each one. And so for N2, which would equal O2, these concentrations would be equal to one another because they're x and x, I would have 0.08662 as my concentration. And then for NO concentration, it would be 0.175 minus this value right here times 2. So 2 times 0.08662. And then doing that on your calculator, you end up with a concentration of 0.00177 would be my molarity of my NO at the end. All right, there's a nice table problem.